Hey Alyssa, this is the one I think that you were talking about. If it's not, let me know. Converting a 16,480 square miles to square centimeters, we're going to use exponents where needed. This is actually the answer to the next problem. So I think you typed in the wrong problem, the answer into the wrong problem, because it's exactly what you have typed into the other one. So you might want to go back and look at that. So 16,480 over 1. This is miles because it's squared, right? We're going to go to square centimeters. So first we've got to go from miles to feet. So actually, let's rewrite this. Let's do miles squared, just so we don't have to take up all the room. We're going to put 5,280 squared feet squared over 1. I'm not going to square the 1 because 1 times 1 is 1, right? So you can square it, but it's a wasted effort. And that's miles squared. So this cancels this. Now let's go from feet squared to inches squared. I've got 12 squared inches squared over 1 squared foot squared. That cancels that. Now we're going to go from inches to centimeters. So I've got 2.54 squared centimeters squared over 1 squared inch squared. That cancels that. Now, we're just going to write this down because we have a denominator of 1 all the way across. 1648000 5280 squared 12 squared 2.54 squared space centimeters squared. All right, when you start putting this exponent in right here, it's going to pop open that that box, that math character box. And when you get through, you're going to want to, actually, I think I have it typed so that you just type centimeters squared right in the box. I'm not sure. I don't remember. But if you type it in like this and submit it, and it didn't automatically mark it right, I will mark it right. If this little space thing is an issue, if it's just a format thing of a space being in the wrong place. But this is what you're looking for, okay? Not this right here. That's not the right answer, obviously. All right, that's all I got for right now. Hang on, let me check your assignments or your messages and see if there's any more from you. All right, so you had one more. This is from the semester exam. You wanted to know, it looks like you got really close. There was some type of a rounding error. I'm not sure what happened. So let's look at how to do this one. You've got 310 degrees. That tells me that is going to be in the 4th quadrant. So I'm going to just draw a quick little Cartesian system here. That is the 4th quadrant and only the 4th quadrant. So we have 8 degrees, or 8 is the length, and 310 degrees. So if this is 90 degrees from here to here, and this is 90, so that'd be 180 from here all the way to here. This would be 270. So all the way around here is 270 degrees. So we've got to take 310 minus 270, and that is going to be 40 degrees, right? Yes, so 40 degrees. So we would have a length of 8 right here, and this would be 40 degrees, which means this would be 50 degrees, and this is the one we're looking for. So we draw our little line here. This is going to be a negative u, because u is the y-axis and r is the x-axis, right? So positive r, negative u. So 40 and 50 makes that last 90-degree angle. So we're going to look for the sine and cosine of theta. So that's going to be Katoa. I always like to write it because that way I remember. I forget if I don't. So we have the sine of the opposite, which would be negative u, over the hypotenuse. So that would be, this is a length of 8 here. And I can erase this little 40. I don't need that anymore. So that's going to be, the hypotenuse is 8. So 8 times the sine of 50 degrees is equal to negative u. And then we would have 8 times the cosine of 50 degrees is equal to r, because that would be an adjacent. R is adjacent to 50 degrees, and negative u is opposite 50, so opposite and adjacent. Okay, so now we just have to solve. So you pull up your calculator, and I'm going to see if I can figure out how you got 512 R and 616 U, because you're just off by a couple decimal points, a couple hundredths in each place. So 50 sine times 8 is 612 rounded up to 2 decimal places. That's going to be 613. And it's a negative. So 6.13 is equal to negative u. We don't want a negative variable, so we swap it. So it's negative 613 u. I need a decimal point right there. And then here we've got, let me look at this again. So if you said 50 sine, and you just took 0.76, so let's do that, 0.76 times 8. No, that would not give you the right number either. So let's say you did 0.766 times 8. That still wouldn't give you the right number. So I'm not sure how you got negative 6.16, because 50 sine, that, I mean, I don't know what else to tell you. That would be negative 6.13 u. All right, so let's look at cosine. 50 cosine. And then I leave it in the calculator. But if you didn't leave it in the calculator, that'd be 0.642 or 0.643, right? Let's do the calculator one first. Times 8. That would be 5.14, and it wouldn't round up. That'd be it. But if you did 50 cosine and you did 0.643, let's say that rounded up. Let's say that's what you did. 0.643 times 8, it'd still be 5.14 either way. So I'm not sure how you got a different value there, but that's going to be what you want. That would be how you would write that in rectangular form. So I'm not sure what you did to get here. I'm not sure what happened so that you're looking at these different decimal values. So go back and look at your notes and your the way you solved those problems and check it out again, okay? That's what you need to do. I'm wondering if you used the 40 degrees instead of the 50 degrees. I don't know if that would make that big of a difference, or that minor of a difference, I should say. So maybe that's where you messed up. I'm not sure. Let's try it and see. If you did 40 degrees, so 40 sine times 8 is still 514. So even if you use the 40, you'd still get 514. So 50 cosine, oh, but you'd be getting 514 for here, not for here, because they would be flipped, times 8. Yeah. Yeah, you would have just gotten the opposite numbers if you had flipped it. So I'm not sure what happened for this problem, but go back and look at it again. Look at your notes and see where you messed up. That's all I know to tell you on that, because you should have gotten, even with rounding, you should have still gotten the same numbers here. All right, that's all I've got. I will see you next semester.